To make a quick correction to the development length equation for straight bars in tension that I did previously. I looked at the 2019 code and it's slightly different. And what's different is, let's see if I can do this. I want to draw here. Um, is this right here? There's a grade factor now that has to do with what grade steel you have. This is the same. That's not changed. This is the same. They call it the casting position factor now. So that, remember how I said if you do it upside down, it depends how much concrete's below it. So that's the same. What I've added to this slide is exactly what spaced far apart means. If the cover, which is from the outside of your beam, so I'm doing this on my computer, so I can't draw as nice as on my iPad. If that is at least 3 bar diameters, and this spacing here is at least 6 bar diameters, the factor is only 1.2, but if it's less than that, the factor is the 1.5. I didn't really explain that previously. Another new thing that I missed last time is when you get these two, the top bar effect and the epoxy effect, when you multiply them together, you don't have to go over 1.7. So for example, if your top bar was 1.3 and your epoxy factor was 1.5, that multiplied out is 1.75, but you don't have to go over 1.7. This is the same as before. And then this is the new one. If you have grade 40 or grade 60, FY is 40 or 60 KSI, then you just have this factor of 1.0. But we do have the advent now of high strength rebar. And so if you have high strength rebar, you need longer development lengths. This is the same. And the simplified table is slightly different now, only because, let me get myself out of the way, only because you have this grade factor on there now in all of these. But otherwise, that's all the same. And that's the difference. And so I'm using a new tool called VidGrid, and we'll see how this works.